the Electrical Masters exam format has changed. The closed book portion of the exam has been deleted. The exam is now fully open book. This means that during the exam, test takers are permitted to consult reference materials such as the National Electrical Code, or NEC, textbooks, and other approved resources to answer the questions. The shift in format places a greater emphasis on the ability to locate, interpret, and apply relevant information from these resources, rather than relying solely on memorized knowledge. Preparing for an open book exam requires a different strategy than preparing for a closed book exam. Firstly, it is essential to become thoroughly familiar with the structure and content of the NEC and other reference materials you plan to use. This includes understanding how the code is organized, where to find specific information, and how to interpret the language used in the code. Secondly, practice using your reference materials to answer a variety of questions. This will help you develop your skills in locating the relevant information quickly and efficiently. It is also important to understand the limitations of your reference materials. The NEC and other codes provide minimum safety standards, but they do not cover every possible situation. In some cases, you may need to use your judgment and experience to apply the code to a specific situation. Thirdly, familiarize yourself with the types of questions that are typically asked in the Electrical Masters exam. This will help you to focus your studying and practice efforts on the most important topics. Look for practice exams and study guides that are specifically designed for the Electrical Masters exam. These resources can provide valuable insights into the types of questions you can expect to see on the exam and the best strategies for answering them. When preparing for an open book exam, it is important to focus on understanding the underlying principles and concepts behind the code requirements. This will allow you to apply the code to a variety of different situations, even if you have not encountered them before. Focus on understanding the definitions of key terms and concepts. The NEC and other codes use specific terminology, and it is essential to understand the meaning of these terms in order to interpret the code correctly. Understanding calculations is also important. Many questions on the Electrical Masters exam will require you to perform calculations to determine the appropriate size of conductors, overcurrent protection, and other electrical equipment. The open book format does not eliminate the need for thorough preparation. While you are allowed to consult reference materials during the exam, you will not have time to look up every answer. You need to have a solid understanding of the basic principles of electrical theory and the NEC in order to answer the questions efficiently. It is crucial to practice time management during your preparation. The Electrical Masters exam is typically timed, so it is important to be able to answer questions quickly and efficiently. Practice taking time practice exams to get a feel for the pace of the exam. Familiarize yourself with common electrical formulas and calculations. Being able to quickly perform calculations will save you valuable time during the exam. Understand how to use the tables and charts in the NEC. The NEC contains many tables and charts that provide information on conductor ampacity, overcurrent protection, and other electrical equipment. Be familiar with these tables and charts so you can quickly find the information you need. Pay close attention to the question wording. The questions in the Electrical Masters exam can be tricky, so it is important to read them carefully and understand what they are asking. Look for keywords and phrases that can help you to identify the correct answer. Eliminate incorrect answers. Even if you are not sure of the correct answer, you may be able to eliminate some of the incorrect answers. This can improve your chances of guessing correctly. If you are unsure of an answer, mark it and come back to it later. Do not spend too much time on any one question. If you are stuck on a question, mark it and come back to it later. This will allow you to focus on the questions that you can answer easily and avoid running out of time. Review your answers before submitting the exam. If you have time, review your answers before submitting the exam. This will give you a chance to catch any mistakes you may have made. It is also helpful to tab your NEC to quickly find the section you may need to reference. A good approach is to use permanent tabs for frequently referenced articles and sections. The removal of the closed book portion simplifies the testing format and places emphasis on practical knowledge. In the NEC, Article 90, One states that the code is not intended as a design specification or an instruction manual for untrained persons. It focuses on the aspects of safety. Understanding the NEC is the main ingredient to passing. Electrical theory is the next focus. Electrical theory concepts include Ohm's law, series and parallel circuits, power calculations, and transformer operation. Understand the relationship between voltage, current, and resistance. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. Be able to apply Ohm's law to solve for any of these variables. Understand how to calculate power in a circuit. Power equals voltage times current, or power equals current squared times resistance, or power equals voltage squared divided by resistance. Be able to calculate the total resistance of series and parallel circuits. In a series circuit, the total resistance is the sum of the individual resistances. In a parallel circuit, the reciprocal of the total resistance is the sum of the reciprocals of the individual resistances. Know the basic principles of transformer operation, including the relationship between voltage, current, and turns ratio. Understand the concept of impedance and how it affects the flow of current in an alternating current or AC circuit. The exam also focuses on conductor sizing and overcurrent protection. Understand how to size conductors according to NEC Table 310.16, based on ampacity and ambient temperature correction factors. Be able to apply voltage drop calculations to determine the minimum conductor size required for a given circuit length and load. Understand the different types of overcurrent protection devices such as fuses and circuit breakers and their applications. Know how to select the appropriate overcurrent protection device for a given circuit based on conductor ampacity and equipment ratings. Grounding and bonding are essential for electrical safety. Understand the purpose of grounding and bonding and the requirements for grounding and bonding electrical systems. Know how to properly install grounding and bonding conductors and equipment. Understand the requirements for grounding electrodes and the methods for testing grounding electrode systems. Wiring methods and materials are also covered in the exam. Understand the different types of wiring methods such as rigid metal conduit, electrical metallic tubing, or IMT, and non-metallic sheath cable, or NM cable, and their applications. Know how to properly install wiring methods and materials according to the NEC. Understand the requirements for cable support, spacing, and protection. Motor circuits and controls are important components of many electrical systems. Understand the requirements for motor circuit conductors, overcurrent protection, and control equipment. Know how to calculate the full load current of a motor and select the appropriate conductor size and overcurrent protection device. Understand the different types of motor starters and control circuits. Special occupancies and equipment are covered in the NEC. Understand the special requirements for electrical installations in hazardous locations such as flammable liquid storage areas and grain handling facilities. Know the requirements for electrical installations in healthcare facilities such as hospitals and nursing homes. Understand the requirements for swimming pools, spas, and hot tubs. Finally, safety is paramount. Always follow safe work practices when working with electricity. Wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. De-energize circuits before working on them and verify that they are de-energized using a voltage tester. Lockout and tagout procedures are important to prevent accidental energization of circuits. Be aware of the hazards associated with the electricity, such as electric shock, arc flash, and arc blast. Understand the procedures for responding to electrical emergencies.